I want to take a few minutes and look at some graphs of some radical functions here. So when we're graphing radical functions, we're going to start with the table of values here and just look at what the graph looks like. And then we'll move from a table of values and be able to just graph it without the table of values and know where the graph is. That's our goal. So we're going to start with the graph of y equals the square root of x. And so we can just crank out some values. For example, when x is 0, y is 0, we have the square root of 0. When x is 1, the square root of 1 is 1. When x is 4, the square root of 4 is 2. And the square root of 9 is 3. The square root of 16 is 4. And we can go to our graph. Let's put some values here. 1, 2, 3, 4, 5. And plot those points. 0, 0, 1, 1, 4, 2. Now notice I didn't put 2 or 3 in here because that would give us decimal values. And we want to avoid that. So 3, we're just graphing some points to give us some reference. There it is. And so we get, it's not a line, it's a curve. Looks like this. Also notice we did not use any negative values because you can't put a negative number into a square root. All right? So that's what the graph of the square root of x looks like. It has a domain of all numbers from 0. The lowest x value is 0 to infinity. The range, the y values, there's no y values down here, but there are y values starting at 0. So our first y value is at 0, and then there's y values all the way up, and it goes up to infinity. It might look like it flattens out, but it doesn't. So the y values are from 0 to infinity. All right? What about cube root? Well, we can plug in the cube root of 8, and that gives us 2. We'll plug in the cube root of 1, and that's 1. Cube root of 0 is 0. What about negative numbers? Can we take the cube root of negative 1? Sure thing. Cube root of negative 1 is negative 1. Cube root of negative 2 is negative 2. I'm sorry, cube root of negative 8 is negative 2. And we can plot those points. Put some numbers here on our axes for scale. 0, 0, 1, 1, and 8, 2. So we get a similar curve, but notice it's not as high or not as tall as this blue one above. Negative 1, and negative 8, negative 2. And there's our graph. Now notice here that the x values will be the domain that is. The domain will have all real numbers because it goes forever to the right, goes forever to the left. You can put anything you want into this equation. So the domain is all real numbers. That's from negative infinity to infinity, all numbers. The range, those are y values. Well, this is going down forever here. So there will be y values as low as you want. And this is going to go up forever. So keep climbing slowly. And so the y values will go up to infinity also. So the range is all real numbers for this. All right? So that's for a square root and a cube root. So what happens if we have a function like this? The cube root of 2x minus 8. Well, let's graph it, and we'll find out here. Let's get this stuff out of here. So the cube roots is under functions, miscellaneous. You can use the nth root. This is on Desmos. You can download the app or go to desmos.com and open up the calculator, desmos.com/calculator. We should put you don't have to, but we should put a y equals in front. So y equals 2x, and underneath is minus 8. All right. And what happens? Well, it looks kind of like our graph did before, but it's moved. And it's changed a little bit in steepness. But the key thing here is that it's going to go up forever. Notice that's all, it keeps going up, and that the domain It keeps going out. Okay, so you can put any x number in there. Okay, negative, same thing, and it's going down forever. So that's kind of what the picture looks like. So it's very similar. So, oops, come back to our problem. Here we are. The domain is all real numbers again, and the range is all real numbers. Again, this is a cube root. All right, that's important. It's cube root. Square root's a different story, and a fourth root, we'll look at those next. But all real numbers will work for the x's, and the possible outputs for the range are all real numbers. So what happens in general, all right? A quick explore here, and we'll come back to our Desmos. So what happens if we have fourth roots and fifth root and sixth root? All right, so let's go back to my equation here, okay? So if we have fourth root or fifth root, we can explore this really nicely with Desmos. Now, we could just type, first of all, y equals the fourth root of x. There's the fourth root of x. All right, and we could type y equals the fifth root of x. The fifth root of x. And there it is. I'll turn off the, so there's the fifth root of x. It looks a lot like the third root. Now, one nice thing we can do in Desmos, and this is pretty handy to even do yourself, I'm going to get the nth root, but instead of putting a number there, I'm going to put a variable n, and what it's going to do, it should ask me for a slider. So I'm going to click on that slider and say, yeah, I'll take a slider. Thanks a lot. All right. So right now this graph you're looking at is when n equals 1. So this is the first root of x, and I'm going to change this to step by ones. Okay, there we go. All right. And actually we need to make it go from 0 up to whatever, 20. Okay, because we're not, the index has to be whole numbers. Okay, so there's an index of 1, there's an index of 2, there's the cube root, third root, fourth root, fifth root, sixth root. Do you see a pattern? Seventh root, eighth root, 9, 10. Okay, what happens? It just starts to get real sharp here. See that little bend? All right. Again, it's still going up, but a 20th root, an even root, is going to look a whole lot like a square root. Okay, so 20th root, and then odd root, there's a 9th root. It's going to kind of look like a cube root. Okay, see the pattern there? All right, so in general, we can generalize this. If we have y equals nth root of x, and that's an even integer, an even root, well, it's going to look something like this. If we have y equals the nth root of x, and n is an odd number, well, that's going to look similar to a cube root, like this. Okay? Now, one last thing we want to investigate here. If we have something like y equals, let's say let's go square root. All right, let's go to square root. Stick with square root of, let's say x plus 3 and minus 1. Okay, now we're going to see what happens when we do these two things. What happens when we put a number out here, and what happens when we add or subtract a number inside. Okay, so let's do a quick investigation here. And so we're just worried about square roots here, right? So now we could always make a table of values there, but some nice patterns show up. So a quick exploration is handy. So here's what I'm going to do. I'm going to put x plus, and I'm going to just pick a letter C, and what I'm going to do is makes a slider here for us. Okay, and I'm going to make this go by ones. All right. Okay. So watch what happens. I'm going to put that to 0. Right now, this is the graph of the square root of x plus 0. Notice the C value is at 0 there. Okay, there's our graph. That's what we expect. Now, when we have x plus 1, there's the graph. Okay, watch what happens. Here's x plus 2, x plus 3, x plus 4, square root of x plus 4, that is. So this is the graph of the square root of x plus 4. Okay, so what's happening as that gets bigger? It's moving. You see that? It moves to the right. So in fact, this is the square root of x plus 9. Notice where that's touching. It's at negative 9. So it's moved 9 spaces to the side there. And if we go this way, it moves 9 spaces to the right. Okay? Now let's go ahead and put that back to 0. So that's just the square root of x right there. And now I'm gonna add in another number that's outside, okay? And so that's we'll call that d, and I'm gonna make that go by ones. All right. Now watch what happens. Okay, there's right now that's the square root of x plus 0 plus 0 on the outside. What happens when I add a number on the outside? Okay, well, there's so that's the square root of x plus 1. Here, let me do this just to make things easier so you can see it better. Okay, there we go. That's the square root of x plus 1. Square root of x plus 2. Square root of x plus 3. Notice it's the same shape. Square root of x plus 4, plus 5, plus 6, plus 7, but it's going up. So that's the same shape going up, all right? And then if we go down, this is square root of x minus 1, minus 2, minus 3. Square root of x minus 4, square root of x minus 5. So it's going down when we go negative. So what's happening is all that's changing is the starting point. Okay? So let me put back that c in there. So what happens if let's see what we were looking at again, plus 3 minus 1. Okay, so if the number inside goes to plus 3 and the number outside goes to minus 1. Okay, so what happened is this. Notice it's the same shape, but this point right here has changed. Let's see, we should be able to, there it is. That starting point is negative 3, 1. So what you're looking at is this. This is the equation. Y equals the square root of x plus 3 plus 3. Then we go on outside minus 1. Okay? So, let's go a different color. All right, so okay, so the sliders are out of there now. Okay, this is just the graph of x plus 3, the square root of x plus 3 minus 1. So, all right, so what's the point here? All right, so this little graph right here that I'll steal a copy of. All right, so that little graph is a graph of x. The square root of x plus 3 minus 1, okay? So the point being, this moves it left. I know it seems like it should move it right because it's plus, but left and right are backwards. Left 3 and down 1. So we should expect it to look the same, but it's going to go left 3 and down 1. We'll spend more time on that as far as the movements and practicing the movements. But for now, it's good to just understand that it's going to be the same shape as the square root of x, kind of like this. Okay, it's going to be the same shape, but its starting point is left 3 and down 1. Okay, and then the only last thing that we'll kind of investigate is this. If we throw a negative in front, watch what happens. Ready? Negative. A negative flips it upside down. Okay, same thing if I come back here and I put a negative in front of this, flips it upside down. And so if we move it, okay, different values of C and D, it's going to be flipped upside down. Notice this one has a starting value of positive 4, that's positive 4, positive 1. The opposite of that C value, and that D value is 1. All right? So that's the idea. That's how it moves there. All right? So, well, then let's leave it at this. Okay, one more thing about radical functions. We can use radical functions. Here's an equation. We have the rafter length of a house. The rafters are these things that hold the roof up. Can be found using this function, L equals W over 2 times S squared plus 1, where W is the width. And so we got our function. W is the width of the building. S is the slope. So we can say, all right, let's find the slope. Now we're looking for the slope. We know we have a 240-inch wide, so that's W building, and we have a rafter length of 140. So we can use this to figure out what the slope would be. So we measure those two things. So rafter length here is 140. We're going to plug that into our equation. L equals W over 2, square root of S squared plus 1. So L is 140. W is 240 over 2 times the square root of S, which we don't know, plus 1. So we can solve this. Let's simplify that. And let's divide both sides by 120. Now we could go decimal, but it's probably a little easier just to simplify this to 7/6, at least for now. If we want to go decimal, we can make that a decimal in a second. How do we get rid of that square root? We're going to square both sides, right? Okay, so if we square both sides, we shrink this up. So if we square both sides, we get 49/36 and S squared plus 1. Let's get that 1 out of there. Minus 1, minus 1. So that gives us S squared. Now, this is, we're probably going to go decimal here in a second, but 1 is 36 over 36, right? 36 over 36. So 49 minus 36 gives us 13. All right. And now we can square root. And we're going to have to, it's a square root of, that's the exact answer. Or we can go to our calculator. Let's open that up. Square root of 1336. Square root of 13 divided by 36. And we get 0.6. All right. So the slope is 0.60. That's good enough there for us. Okay. So that's how we can use a function in an application of a problem. All right, we'll stop there. So we got the idea of how these radical functions work. We got a basic idea of how they move. For now, you'll have a couple problems where we'll do this. You can use a graphing calculator to kind of help, but we're going to start to know what to expect and know where it is without using the graphing calculator. All right?